This is The Future Of, where experts share their vision of the future and how their work is helping shape it for the better.
I'm Jessica Morrison. Mass extinction events are something we're taught about at a young age, from the knowledge that dinosaurs were once the dominating species of life on this planet before they were all wiped out. But it might surprise you to know that since the formation of life on Earth, 541 million years ago, that there have been 5 mass extinction events. With the undeniable impact that humans are having on the planet and plant and animal species, scientists are now asking the question, are we in the middle of a 6th mass extinction event? I sat down with world-renowned organic geochemist and Australian Laureate Fellow Professor Kliti Grice to discuss this topic and more. First, we'll start with, what are we only now just learning about past mass extinction events?
Okay, I guess anyone who's heard of the extinction of the dinosaurs has known about at least one of those events. And the dinosaurs are the most notorious victims of a mass extinction event 66 million years ago. But even worse events have previously occurred, at least 4. For instance, the Great Die-In, the largest of the 5 non-mass extinction events, occurred 252 million years ago and was associated with Siberian volcanic eruptions when this massive supercontinent, Pangaea, was formed, and likely contributed to the event, leading to global warming of the planet, release of toxic gases and metals, ocean acidification, depleted oxygen levels in the oceans, and it was probably a cascade of events that led to the observed catastrophic event of the mass extinction event 252 million years ago. So today we do really worry about the current global warming and the COVID-19 pandemic, has probably brought to the fore in people's minds about how one event can impact the lives of all people from all nations. And while I guess this pandemic is nowhere near a mass extinction event, it does link up the idea of, I guess, a widespread global event that severely impacts life and ways of life. Things like increase in frequency of forest fires, which Australia has experienced, ocean acidification, expansion of oxygen minimum zones, degrading shorelines, melting ice caps, increases in pollution such as from phosphorus and nitrogen inputs, and now we're even having plastic pollution in the oceans. And these are all points of serious concern today. So I guess this is, looking at the past, we've seen some of these changes that have happened, and we're also experiencing a lot of changes in our own environment today.
You've recently been awarded a 5-year research project from the Australian Research Council to improve our understanding of past extinction events and other evolutionary processes. Can you give an overview of that project and what you're hoping to learn from it?
Okay, so this is a laureate project, and it aims to unlock an untapped record of our planet's past by analysing fossil material for new evidence of natural products in the form of biochemicals or even their recognisable degradation products, which we call biomarkers or molecular fossils. The well-studied inorganic fossil record has provided a framework for understanding major events in the evolution of life and our planet. However, this project aims to significantly advance current perceptions by assessing parallel but rarer organic record of ancient organisms which are entombed and exceptionally preserved in concretion fossils, and determination of the mechanics and controls of what is rapid, glue or biofilm entrapment of these organic remains will contribute valuable new information about geobiological functionality. From an extension of the fossil and biomarker record or a new way of interpreting our planet's past with improved understanding of extinction, environmental change and adaptation. So we're going to have 2 parts of this project put together. One is to look at the preserved uncontaminated fossils, including soft tissue in these encapsulated concretions from different geological settings and timeframes. by various multidisciplinary analytical techniques to answer ecological, paleo, environmental and evolutionary questions of contemporary relevance. And the other part of the project is to perform laboratory controlled time experiments which artificially grow concretion enclosed fossils. This is like basically making a fossil in the lab, and this will be done with high school students so they can come and make their own fossils and see how the fossil is growing. And we hope to identify the optimal growth conditions and establish the role of microbes and the biofilms that they make in their formation.
That is very cool. And what about if there's any high school teachers listening who want to get involved, how can they do that? Can they just reach out to you by email or something?
Yeah, sure. We will have an outreach coordinator in this project who can be contacted, but in the meantime you're welcome to contact me, and we have various avenues of linking up with high school students through a number of programs.
That would be amazing, I would imagine. So we'll make sure we pop your details in the show notes so anyone can get in touch. How does the understanding of past extinction events help us today and going into the future to sort of understand what's going on?
Okay, I guess we really need to be able to understand what happens before, during and after an extinction event in the past, so that we can recognise the signs of trouble and consequences of the inaction. Also, we can learn about the resilience of certain organisms and which life forms might compete best under certain extreme conditions. So a bit of Darwinism at its acutest.
So based on your understanding of past events, what's the likelihood of a naturally occurring mass extinction event happening in our lifetime?
Okay, that's an interesting question. Apart from the Cretaceous asteroid that impacted the non-avian dinosaurs and other organisms, the other 4 events were thousands or more year events. So unless we're hit by an asteroid or a comet, in advance you would probably know if an asteroid was going to hit Earth. And we have no evidence this is imminent. I thankfully cannot see a mass extinction event happening in our lifetime. If naturally occurring means not caused by humans though, then I guess about every 540 million years is possible, and a chance of about 1 in 1 million within a 100-year lifetime, if that makes sense.
Yeah, okay. So it's not happening in the very near future, which is good for our listeners to know, so that's a good thing. Do you believe that we are in the middle of a human-induced mass extinction event?
No, but at worst we are potentially at the very start of such a concerning human-induced event, but certainly not significantly progressed on situation of mass proportions. And whether or not it becomes one depends on environmental trends persisting over the next 100 to 1,000 years, I guess. However, we are at a very concerning early point, experience significant changes nonetheless due to rapid and dramatic changes that are occurring to Earth's climate. Changing the climate will impact species, and humans are perhaps relative susceptible species. All organisms will either die or adapt. Now, human extinction is the hypothetical end of the human species due to either natural causes such as things like asteroid impacts, large-scale volcanism, or anthropogenic, which is human-induced, include things like climate change, global nuclear annihilation, biological warfare, and ecological collapse. There's a relatively low risk of near-term human extinction due to natural causes. The likelihood of human extinction through our own activities, however, is a current area of research and debate. I guess today's proposed extinction is very different. It's an unnatural event and it has the magnitude of a mass extinction, but this time is not brought about natural occurring phenomena, but as the direct result of our activity of one individual species on all the rest.
Is there any way to minimise the chances of another mass extinction event from occurring?
Interesting question. So I guess we know from the geological record that the cause of mass extinction events, whether it be a meteorite impact or massive volcanic eruptions, led to dramatic, rapid change to Earth's climate. While I guess we cannot control large-scale natural events to minimise the chances of a human-induced mass extinction event, we need urgent climate action to mitigate the climate changes witnessed through the current anthropogenic, the human epoch, which on a geological scale are progressing at a relative rapid rate.
Well, that leads me pretty well to my next question, Kliti. Extinction events seem like such a bleak subject to want to research and talk about. But why do you find it so fascinating? What inspired you to get into this field?
I don't think it's bleak at all. I think it's actually very uplifting to know that even under extreme stress, our life actually finds a way. And sure, some species experience major evolutionary events which can be fatal, but what's nice is that new niches of organisms flourish, leading to new, more evolved forms. And actually, we humans wouldn't exist if we did not have the dinosaur extinction. And I guess, as Charles Darwin quoted, it's not the strongest of the species that survives, nor the most intelligent, but rather the most responsive to change.
Positive outlook. What does it feel like to find a fossil as a researcher?
A molecular fossil or a fossil? A molecular fossil is the exciting part because you can't see it.
Okay, well, tell me about that. What is it like?
So you know what a fossil is, like a remain. You might have seen in the museums a trilobite or
the little
ammonite
shell-looking. Yes, yeah.
What we actually do is look at what molecules are within the molecular fossils. So you can actually see those, but they tell you a wealth of information about the organism, what it is, what it might have eaten, what its ecosystem was like, how it was preserved, what the environment was like. And we're talking about fossils, organisms that are extinct today. So we might get a fossil which, an example of one is the Tully monster, is an organism that is called a bilateral, so it's got two halves. And it's quite an interesting organism because it's got an eye bar on its back and it's got a proboscis mouth, and it was originally thought to be an invertebrate, but because it's got cartilage type material and it's got eyes and it's got teeth, then it's been reclassified as a vertebrate. So we're actually looking at its diet, how it lived on the ocean floor. It's extinct. It could be related to some of much earlier creatures on Earth from the Cambrian. So yeah, it's really, really quite exciting to have something which is extinct and really pull it apart.
Yeah.
What's a future area in this topic that you would love to research, Kliti?
I guess in Australia we'd like to really look at life's tipping points and resilience of life throughout Earth history by embracing and combining various disciplines, multidisciplines such as geology, geophysics with biochemistry, genomics, big data, numerical modelling, to actually produce a revolutionary 4D framework that is in space and time as a foundation for policies, practices and assessments of ecosystem resilience. We also don't know a lot about the biodiversity of the deep ocean basins of today, let alone the diversity was like what it was like in the geological past. So yeah, we really want to address what is meant by resilience of life on Earth and actually learn from the past to help save and protect our own environment and planet for the future.
Fascinating. Thank you so much, Kliti, for sharing your knowledge on this topic, and we really, really appreciate you coming in. Where can listeners go to find out more about what you do?
We have a website, the WA Organic Isotope Geochemistry Centre at Curtin University. You can email me. We have a big team of researchers, PhD students and research fellows. We will have an outreach coordinator soon. So yeah, just check out our website, check out the people, our instrumentation, our labs. It's really exciting. We will be having probably a launch of the fossilization lab in next year, we hope, for high school students, and yeah.
Fabulous. We'll make sure we put all of those details in the show notes for people to access. You've been listening to The Future Of, a podcast powered by Curtin University. If you've got something out of this episode, please remember to share it and subscribe to our podcast. Until next time, bye for now.